All right, here's our video, how negative ions are written. And we'll do positive ions also. So a negative ion, just in the name, let's get our pen going. Let's use red. So a negative ion will be an anion. So they're negative. Whereas a positive will be a cation. So just think cats are positive. Think that. Maybe that'll help you. Or with what other mnemonic device you want to use. So there's these endings that you'll see. And you'll see the word either "ide," right? Or you might see the word "ite." And again, the endings of these words. Or "ate." And if you see those, then you know you're dealing with a negative ion. For example, on the periodic table, you'll see fluorine, let's say. And fluorine is a halogen. It's the most reactive element on the periodic table. And if fluorine becomes an ion, then it becomes fluoride. So you see that "ide" right there? That "ide." Right? Let's put an arrow. The "ide." So if you see an "ide" or an "ite" or an "ate," let's put an "a" there, fix that "a," then you know you're dealing, again, with ions. So let's get a clean page, and or why don't we just draw it in the sun? Why not? Draw in the sun with white. See if we'll use white. So another one we'll see, let's say you had sulfur. Drawing in the sun today. Well, there's sulfur, and there's the symbol sulfur, S. And if sulfur is an ion, then it could be sulfide. And there's the "ide" right there, that "ide." And you might also see sulfite. That's a negative ion. Or sulfate. And we'll talk about how do we distinguish between those three. So let's get a clean page. Let's get a clean page going. And we should change the color. Let's use red. So let's go back to, first of all, we should know what an ion is. And I have videos on ions, but if you don't know, an ion has, fix that, an unequal amount of protons and electrons. So in other words, an ion will have either more protons than electrons, or vice versa. Or vice versa. So ions have a charge. They have a charge. And again, they could be negatively charged or positively charged. So you can either see a plus sign or a negative sign like you see on the batteries. So I'll leave that there for a minute if you want to look at it, if you want to write it, or you can go back, you can always rewind. So let's clear that out. Now let's go back to sulfide. So we take sulfur, and sulfur again has the same amount of protons and the same amount of electrons, so it's not an ion. But if you see that it says sulfide on it, then you know you have an ion, and it's negatively charged. Now, if you see this, it'll say sulfur with a negative sign. So you know that's a negative ion, and you know negative ions are anions. Now, if you see sulfur, and let's say it has a number 2 next to it, and then the negative sign, that means it has 2 extra electrons. Not just 1 extra, 2 extra electrons. And it's still negatively charged. So what do you think this might mean? Right? It has 3 extra electrons. Right? So that little superscript right here, they call it the superscript, looks like an exponent, tells you how many extra electrons the element has if it's an ion, if it's a negative ion. Now, if it's a positive ion, it also will have a number there, but it won't say for extra electrons, it'll be extra protons. Okay, so that's "ide." Now, if we have "ite," sulfite, what you got to remember with sulfite, "ite" and sulfate, that itin 8 is that means there's oxygen is present, right? So anytime you see the ite and the 8, you're dealing with oxygen. So sulfite would have sulfur. It has oxygen, like I said. Now this subscript here on the bottom, it's saying it has 3 oxygen atoms connected to this compound to make sulfite. And then this 2 on the top in the superscript is saying that there's 2 extra electrons. And then we have this negative symbol there. So if you see something like that, that is sulfite with 3 oxygen atoms. And that superscript on top right there is saying there's 2 extra electrons. So the difference between ite and 8, because we know that ite and 8 mean that there's oxygen present, sulfate has more oxygen, right? That's one way to look at it. It has more oxygen, has a higher concentration of oxygen with sulfate. So sulfate, you'll have SO4, and then that superscript can tell you how many extra electrons it has. So again, ite and 8, you're dealing with oxygen. And 8 has more oxygen. There's more oxygen concentration than sulfite. All right, let's clear that out. And again, so if I had, I'll write this down. This is potassium with K, and then I had Cl, potassium with Cl. This is potassium chloride. And you know that ide, so it's potassium, right, which is an alkali. And then we have this gas, chloride. It's not chlorine, it's chloride because the chlorine became a negative ion. And the potassium, when this becomes a compound, the potassium does become a cation, becomes positively charged. But when they're putting 2 of them together, when they put a cation and an anion together, they just use the ending, the last one, which is negative. They use that to indicate the chemical. So even though the potassium is positive, chlorine is negative, they have an equal charge going there. So you won't see like KCl, then just the negative there because the potassium isn't negative. But you may see, if you saw this, let's say you saw sodium, and then you saw fluorine with this 2, well, now the fluorine has an extra electron because it says it right there. Sodium fluoride. Okay, so let's look. What would this be if I gave you nitrite? Nitrite. There's that ite. What is that indicating? Well, we have nitrogen. But again, remember, any ite or 8 means there's oxygen present. And in this case, the nitrite does have 2 oxygen atoms. Nitrogen and 2 oxygen atoms, which is O2, and we breathe in O2. So we know that this is an anion. This is an anion compound. But nitrate, see the 8 is written with 3. And so it has a higher concentration when you see the 8 than with the ite. So just review again, we had ide, then we had ite, and we had 8. So if we had sulfide, that is an anion. But ite means we have oxygen, and 8 we have oxygen present. Oxygen is part of it. And 8 means we have a high oxygen concentration, where ite we have a low oxygen concentration. So if I write, and we'll change the pen, if I write this, what do you think this is? If I said phosphite is a negative ion, right? So it has potassium, and what's present? That's right, oxygen. Oxygen is present. It has 3 oxygen molecules. And this 3 here, this superscript is saying it has 3 what? 3 extra electrons. And there's a negative symbol. So sometimes phosphite, the ite here, could have 2, it could have 3. And if it has 3, that means that phosphate, which is more popular, people know that one better, would have 4. And of course, this 3 on top is saying it has 3 extra electrons. Now, what about something that's positive? Let's clear that out. So we know how to identify negative ions. To identify positive ions, so positive ions have more protons than electrons. And there's one called hydronium we'll talk about. And that'll give us what we need, the suffix onium. Onium is an indication that it is a positive ion. And hydronium is just 3 hydrogen atoms, an oxygen atom, and then we'll put that plus sign saying it's positive. All right, now let's give you one more. All right, let's change it to purple. Put a line here. So what if I gave you ammonium? You already know it's positive because of the onium. And so this will be a cation because it's a positive ion. And that has selenium. Se is selenium. And it has 3 hydrogen atoms. And it has that plus sign saying that it is positive. So that's ammonium, hydronium, and ammonium. And we'll do one more. So if I gave you this, what is it? Tell me if it's a cation or an anion. Right? If I said oxonium, oxonium. Sounds fancy. Oxonium. Well, there it is. There's the onium, so you know it is positive. It's a positive cation. And oxonium, it just has oxygen, and it has hydrogen, right? And it has actually two hydrogens. Plus sign there. Actually, it's not a 2, it's a 3. Not 2, but 3. And you may be noticing that oxonium and hydronium are almost exactly the same. And they are the same. So sometimes you hear it as hydronium or oxonium because look, it's the same thing. It's the same exact bond. All right, so that's our video today.